Today I'm just going to very quickly, in under 10 minutes, discuss how we export 3D models from Fusion 360 into STL files. So STL files have the extension of .stl, which stands for stereolithography or standard triangle language. Effectively, STL is a type of 3D mesh that our slicer software, so Cura, Preform for the SLA machines, Ideamaker for the Raise 3Ds, accept an STL file and can interpret that and generate G code from those STL files. So STL is what we import into the slicer, and G code is what we export from the slicer. So our task is to convert a 3D model in Fusion 360 to an STL file. And there's a couple different ways that we can do that, and it really depends on how many bodies we're trying to export. So if we're trying to export an entire assembly with multiple bodies and components as a single STL file, there's a bit of a different process for that versus if we're just exporting a single STL file, or sorry, a single body as an STL file. We can do that a little bit quicker. So a couple different ways that we can do this. I'll show you my preferred method. But if we have an assembly, so this is a bracket mount that I've designed for my mountain bike, and I just quickly copied and duplicated it for the purposes of having a file that has more than one body or component in it. So if I wanted to export both of these brackets into a single STL file, I need to have both of these be visible. If I have one of the bodies hidden and I export it, it will only export what it sees. So it'll only export one of the brackets. So I'll have all of my components and bodies visible, and then I go to File and Export, and I will give that exported file a name. And under File Type, I need to select .stl just at the bottom here. And it does give me a bit of a warning. So this process going through the file and the export window does take time because it happens on the cloud. So you can expect anywhere between sort of 4 to like 7 minutes, depending on the size of the file and how many bodies and things like that. And then I'll just select a location. I'll just select my downloads folder and then export that. Okay, so that's going to take a little bit of time. Now I've already gone through this process, and you can see here, I'll do a quick preview of what that export looked like. So this is the job status window that does come up when you perform an export. So right now it is exporting sort of what I just asked it to do. There's a status bar. When this whole bar is blue, that means that the operation is complete. And as you can see, kind of nothing's really happening very quickly here. So I can just close that. And if I go to my downloads folder, I've already done this. So this was the file that I exported. So I had both of these brackets visible when I went File Export as STL. And as you can see, both of those brackets are in this file. Now, I also exported, oh, not this one. This one here. So I also exported the file, but only with one bracket visible, and you can see that it only generated the STL for that one bracket that was visible. All right. So that's option number one. Just to recap, File, Export. The other option is to go File and 3D Print. And this print dialog box appears. And under the selection here, you can either select the body in your browser on the left-hand side here, or you can select the body that's on the screen. So I could select this bracket here. Now I can only select one bracket at a time. So this method, the file and the 3D print, is only if you are wanting to export one individual part. I can hold shift and try to select the second body, but it will not let me do that. Then under format, there's a couple different types of formats. Some of these may be desirable depending on what type of software you're using, but for us, we really want that STL file type. OBJ is another one that we might use in programs like Mesh Mixer and things like that, but really we're going to focus on STL. Now there's two types of STL files here. There's the binary and then there's the ASCII. We will primarily always use the binary version. The ASC STL type is an older type of STL file format, and the file format is significantly bigger than the binary option. And that's really the only difference. So we want to keep our files small and compact without sacrificing anything, and the binary option is the best for that. Unit type, so we want to export in the desired unit type. So if I wanted to export this in inches, I would do it in inches. Now, whenever we're exporting in maybe different units than what we've designed for, so my document settings are in millimeters, but maybe I want to export in inches. When we bring that into our slicer software, we just want to do a mental sanity check that our file did actually export in inches and to scale. But generally speaking, I always have my document settings set in the same unit type that I want to export. So my document settings are in millimeters on the left-hand side here, and I'm going to export in millimeters. Now we can preview the mesh. I kind of like to do this. So if you turn that option on and off, it will preview the mesh that is going to get generated, right? And so you can kind of see here what that looks like. I can change the refinement type. So a low refinement type, you can see here that the mesh actually got less dense versus medium. You can kind of see that it got a bit more dense around the corners and curvatures, and then high, it gets a lot more dense around sort of these curvatures. Like this fillet right here, that's where you can kind of notice the big difference between high and low. So really, we're always wanting to export in high refinement because that's going to give us the best representation of the true shape. So that's going to create curvatures that are quite smooth because the mesh density is quite high versus low or medium. So I always export in high. If you have a really complicated design, note that there's these number of triangles. So these are all classified as triangles, what you see here. If I zoom in, see these triangles, right? So that's the structure of the mesh. It basically uses 2,500 triangles to create this mesh. Now, if you're working with a design that's like very complicated geometry, tons of curvatures, and therefore needs a lot of triangles, there is a limit on this in Fusion 360, and if you're ever encountering export errors where it says that the mesh refinement is too high or too many triangles, this is kind of what it's referring to. So for something like this, that's fine. Under refinement options, we could fine tune this if we wanted to in terms of the length of those triangles, their aspect ratio, things like that. I personally never touch these settings. I just leave them as the default. Then under output here, this can often be selected, so send to print utility. Print utility is another piece of software, and we don't use print utility, so we have that deselected. Okay, and then we press OK. And I can change the name of that file, save it to my downloads, and that process happens a lot quicker than the other method to go through the file menu. So if I go and find, there it is there. So this is exactly the same STL file as where I went and did the export with only one of, or the file export way with only one of the mounts visible. It's the same thing, it's just going the file export route is a lot more time consuming. And then the third option where we can produce STL files is we can right click the body in our browser, and then we can go save as mesh, and it brings up the exact same dialog box that we just saw. So that's kind of the other option. And then the very last option is to go up to the tools in the toolbar, and then under make and 3D print, again, the same dialog box happens, and we can select that individual body from our screen or on the browser, and we can preview the mesh. So exact same, it's the same process, the same dialog box, everything like that. There's just a few different ways to access that dialog box. And then when we open up Cura, and in Cura we go File, Open File. We can also just drag and drop that STL file into the Cura onto that build platform. And we select our STL file, click Open, and there it is in Cura. Okay. Okay. And that's it for this brief tutorial. There's a little bit more to know on this in Cura, which we will cover next week. For example, print orientation. The way that I have this print set on the print bed right now is a pretty inefficient way to print this part, because it's going to require a lot of support structures on this red surface right here. The better way to probably print this would be on its side. That'll take much less time and much less supports kind of thing. And we'll cover that next week.